Good morning, everyone. My name is Hong He from Kema Labs. Today it's a really good opportunity to share our DC cable testing activities and also share some information about cable system applied in DC power transmission. I would like to start with a brief introduction about HVDC cable system, then summarize some available cable recommendations and standards. DC cable also compared to AC cable system, there's some special test requirements. And I also would like to share some our testing activities here. And finally, we will look to have some future outlook. If we're talking about HVDC cable system, which means cables and accessories. So we need to talking about two parts. For cables, for DC cable, so far, there's a few different type of the DC cables, but there is two main type of the DC cable, which is mass impregnated paper-lapped cable. Normally you say it's MI cable, and also extruded cable is XLPE. These two types cable is generally applied in the HVDC system. And for MI DC cable, up to date, the rating is maximum reach 600 kV and 2.2 gigawatts. And the XLPE cable is 320 kV is few applications, and last year there's one application is 400 kV is 1 gigawatt. Let's look about accessories. Normally we're talking about the cable accessories. There's two main accessories is terminations and the joints. For terminations, especially for high voltage termination, there's outdoor termination and also GIS termination. It's as were before the presentation talking about GIS connect to the cable, you have GIS termination. For joints, basically you have two types joints. One is factory joint. Basically, this is manufactured in the manufacturing location. This is come with the deliverable length of the cable to the location. Another type is field joint. That means you install the joint on the location, on site. For the field joint, there's also two types. You have a straight joint and also transition joint. Transition joint, which means you have connect to the different two types of cable. So that's why the definition is transition joint. So far, there's some recommendations for DC cable and the DC cable system related for testing purpose. There's only one official AEC standards for DC extruded cable, but only for land cable. For DC application nowadays is also connecting to the wind farm is lots of submarine cable needed. So most situation, the customer follows SIGRI recommendations and also look to the project-based requirements to finalize some specific specifications for testing, control the DC cable system quality. Now I would like to say basically for HVDC cable system testing is similar for AC cable systems testing. There's also have different type of tests. It's depending you are in the which phase of the cable development. For instance, you have design stage, then mostly manufacturer will apply some development tests to check their design. After this design, this type of DC cable is finalized, then normally you need to have two type tests, is type test and a pre-qualification test to check and demonstrate your cable design and also the long-term performance of your complete cable system. By the way, for the type test, it's not only required for cable system, you can only type test for cable, or you can only type test for accessories. But for pre-qualification test, you have to do for the complete cable system. There's also two type tests. Normally you test by the manufacturer factory location. You have routine test and the sample tests. After the cable system is installed, then you need to test after this installation. Here, right side, there's a picture. This is our one project to test 320 kV cable system. This is a pre-qualification test, lasts for at least 1 year. I don't know how well our audience know about the cable system. I can give brief introduction here. Basically, this is DC source. Here's our discharge unit. For the cable system itself, this two is termination, and this part is the submarine cable till here. Here you have submarine cable, we call it repair joint. There's no casing, but only the joint body and self is tested. This is submarine cable. Somewhere here you have factory joint, but normally you cannot see. It's nearly size a little bit bigger than the cable. Then come here, you have transition joint, because this side is submarine cable, this side is land cable. Then come to the land cable, to here you have also land cable joint. Then from this side connect to the termination. This is basically the test setup for this project. For the DC cable, there's some specialty compared to AC cable, because DC cable insulation material is some kind of resistive effect. Because of this resistive effect, is very temperature dependent. Because this temperature dependent, that's why the electrical stress, electrical field will shifting. There's some picture, for instance, when cable, there's no load, no current running on the conductor. It means all layer of the cable is all in the same temperature. At this moment, if we apply the voltage, then you have electrical field is mostly concentrated near the conductor. But if we give the cable as full load, rated current, then conductor getting warm, which means all the cable layer, there's some temperature difference. Then when cable here conductor reach maximum temperature full load, then the electrical field will shifting from conductor side near to the sheath. The cable sheath has the maximum electrical stress. That's why from a testing point of view, there's also one important design. Basically, this is design value about the temperature drop across insulation, which means every manufacturer design their cable should have different design value to define, okay, my cable has how much temperature drop allowed it. For instance, we can say one cable design, they are saying for insulation, you have maximum drop 12K. If they have 12K, then for our testing point of view, during the thermal steady state, for instance, here we have a thermal steady state, the conductor reached the maximum temperature, 72 degrees. Then during this thermal steady state, the delta T, the insulation temperature drop, should be above this desired value, should be above 12K. But in this case, the desired value is 15K. You can say this red line, where during whole cycles, the delta T above 15K. Yeah, same as before, we talking about the DCGIS, there's also superimposed test, but for cable, same, we also have a similar superimposed test. This is our test setup. There's also, you need to have DC source and impulse source. We use a spark gap method to realize this test. There's some two graphs to show what the superimposed test means. Of course, for DC cable, there's also the space charge is an issue. There's also lots of methods. You can use different methods to measure this space charge. But in our lab, we cooperate with TU Delft. We built a measuring table for space charge. We use pulse electroacoustic method to do this test. This is our real test on one real cable system. We have some good results, but the only thing now is still in the research stage, because how to interpret this measurement result and also the interface, how to either for test engineer or for manufacturer to read and understand how that space charge result. We'll also there's also lots of requirement or lots of requests from TSO asking for testing for DC cable about temporary over voltage test. There's one type of the over voltage test is superimposed with oscillating switch impulse. We also did one project for 320 kV DC cable system. This is just one example how that superimposed oscillating switching wave. This is DC. We have oscillating switching impulse on top of that. Now we come to the final slides. The last slides, I would like to say that DC cable, it definitely will grow, because especially in Europe, because it's mitigate the visual impact. For instance, German DC corridors is really famous. There's some mixed with over handline and also DC cable. But the DC cable rating now is some challenge, because for XL's PE. So I think now maximum extruded, especially insulation thickness is around 30 millimeter. It's challenged to produce more heavier and thicker DC cables. That's why the higher rating and also higher thermal capability is a challenge. But there is some prediction also says by after 10 years there will be higher rating for MI and XLPE, even some optimistic prediction. There could be 800 kV cables, but it's a long way to go to have really higher rating cables. But for Asia market, I think especially India and China, I think for DC grid dominated by overhead line, this is for XLPE, I think is mostly not really a hand, it's mostly parallel in the Europe now development. I think China says this year probably XLPE 535 kV is operational, but you never know because this year is really critical situation happened. I don't have really update information from there. Yes, this is basically my information. I hope it will help to give you some valuable information here. Thank you very much for your time.